Welcome to The Explainer. Today, we're going to pull back the curtain on the super complex and honestly fascinating world of automated assembly systems. The powerful engines that build basically everything we use, from our cars to the phones in our pockets. All right, let's dive right in. Here's our roadmap for today. We're going to start with what automated assembly really is. Then we'll get into the powerful benefits and what it actually means for workers. After that, we'll look at the different kinds of systems out there, and we'll finish out by talking about the tough challenges of actually making it all happen. Okay, so first things first, when we say automated assembly system, what are we really talking about? Because trust me, it's way more than just a bunch of robots on a factory floor. At its very heart, it's this incredible system where people, machines, and software are all working together in this highly coordinated dance. The whole goal is to orchestrate every single move with just unbelievable precision, making one seamless production process. You can almost think of it like a human body, right? The hardware, the robots, the conveyors, the vision sensors, those are the muscles and the senses doing all the physical work. Then you have the software. That's the brain. It's handling the planning, the scheduling, and even creating these things called digital twins, which are basically perfect virtual copies of the factory that let you test changes without breaking anything in the real world. So now that we kind of get the different parts of these systems, let's talk about why they're so incredibly powerful. Why are companies pouring billions of dollars into this technology? Well, the results are pretty hard to argue with. The first, and maybe the biggest advantage, is just this huge leap in quality. These systems can do the same task over and over and over again with a level of consistency and precision that, let's be honest, a human just can't match, especially over a long shift. And this is what's so wild. This slide really puts that precision into perspective. We're talking about reducing drilling errors to less than a millimeter. I mean, that's the kind of mind-boggling accuracy you need to build airplanes, where there is literally zero room for error. And this really shows you the big picture impact on the factory floor. You get way higher throughput, which just means more stuff gets made. You get lower product variance, which means better, more consistent quality. And you get way, way less unplanned downtime. It's just this perfect trifecta of efficiency. But of course, all this brings up a huge question. What about the people? It's really easy to see this as a simple story of robots replacing humans, but the reality is so much more nuanced than that. See, instead of just replacing workers, automation actually reallocates their skills. The focus shifts away from things like manual dexterity and doing the same physical action again and again, and it moves towards tasks that really need a human brain. Supervising the whole system, programming the machines, and making those high-level decisions the system just can't. So, and this is so crucial, finding the right balance is incredibly tricky. This quote here really nails the danger of only going halfway with automation. If you don't do it right, you can get stuck with the high costs of all the new equipment and all the same bottlenecks from the old manual process. It's not always the best of both worlds. Sometimes it can be the worst. And that brings us to a really important point. Automation is not a one-size-fits-all kind of deal. There's a whole spectrum of choices, and each one is designed for a very different kind of job. So on one end of the spectrum, you've got fixed automation. This is your classic, super fast assembly line. It's unbelievably efficient and cheap when it's making one single product in huge numbers, but it has pretty much zero flexibility to change what it's doing. Smack in the middle, you'll find programmable automation. This is your compromise. It uses robots and controllers that you can reprogram, so a factory can switch between making different batches of similar products. It's all about balancing that need for speed with the demand for a little variety. And then, all the way at the other end of the spectrum is flexible automation. This is really built for the way we live now. It uses modular cells and collaborative robots to handle lots of different products and really fast changeovers. It's all about being adaptable, not just about raw speed. As you can see here, picking the right approach is a huge business decision. It totally depends on what you need. Are you making millions of the exact same part? Fixed automation is your answer, no question. Are you making small batches of a ton of different things? Then you need to be leaning way more towards flexible. Okay, finally, let's bring all this back down to earth for a minute. Putting these systems in place is not easy, and it is definitely not cheap. So let's look at the very real costs and the practical hurdles you have to clear. Well, for starters, you need a massive amount of cash up front. It's a huge capital investment. But the costs don't stop there. You've got to have detailed plans for how you're going to operate and maintain everything, and this is so important. you have to invest in training your people for their new, more complicated supervisory jobs. Now, this is a really critical takeaway. Even though the benefits seem pretty clear, there's a surprising lack of solid long-term data that proves the return on investment across different industries. And that makes it a really tough strategic bet for a lot of companies. They basically have to figure it out as they go. And that leaves us with one last provocative thought to chew on. We know automation is the absolute master of precision and repetition. But as these machines get better and better at those tasks, what does that free us humans up to do? What uniquely human skills, like creativity, improvisation, or that flash of insight for complex problem solving, what skills will become even more valuable on the factory floor of tomorrow?